This video is for topic 5.10, multi-step reaction energy profiles. And the objective for this topic is to represent the activation energy and overall energy change in a multi-step reaction with a reaction energy profile. So this is going to build off of our previous topic of reaction energy profiles. So as a reminder, an endothermic reaction is a reaction in which energy is going to enter the system. So the total energy of the system will increase. This is usually demonstrated by a positive delta H value. An exothermic reaction is one in which energy leaves the system, so the total energy will decrease. This is often represented by a delta H negative value. When we write or draw our reaction energy profiles, an endothermic reaction will have products at a higher energy than the reactants, and an exothermic reaction energy profile will have the products at a lower energy than the reactants. So let's look at two examples. So here's our first example, and we want to look at how many steps are in this reaction and is this endothermic or exothermic. So first of all, looking at the shape of the reaction coordinate or the graph or the profile, whichever term you want to use to describe this. It has the reactants and then it has the products, and there are two bumps to the curve in between. So since there are two bumps to this curve, this is a two-step reaction. So the first step is represented by the first curve, and then it drops down to the intermediate, and then the second bump represents the second step to the reaction. If we compare our reactants to our products are lower in energy, therefore this is an exothermic reaction. So you can also see that there are two activation energies. So there's the activation energy of the first step, which goes from the reactant to the top of the first bump. And then there's the activation energy of the second step, which is from the intermediate or the dip in between the two bumps to the top of the second bump. So that would be the activation energy of the second step of the reaction. The total energy change of the reaction is just the difference between the reactants and products. So since the products are lower than the reactants, this means it is an exothermic process. So this particular reaction energy profile has a little bit less detail, but we can still gather some of the same information. So how many steps are there to the reaction? So we have our reactants at point A, and we have our products at point D. And then there are three bumps in between with two valleys between our reactants and products. So that means that this would be a three-step reaction. So the first step of the reaction is going from A to intermediate B. The second step of the reaction would be going from B to intermediate C. And the final step of the reaction would be going from intermediate C to product D. So this is a three-step reaction. When we compare the energies of our reactants A to our products D, the energy of our products is higher than the energy of our reactants. So that means that this is an endothermic reaction. So if the reactants or if the products are higher in energy than the reactants, it is an endothermic reaction, or there is an increase in the total system energy. So that's how we analyze a reaction coordinate diagram or a reaction energy profile for a multi-step reaction.